Hi guys. Okay, let's get started. Today our lesson goal is to recall, because you did learn these a while ago, the exponent laws. These are shortcuts that will help you simplify exponents. What does simplifying mean? Simplifying means to write many items as a single power. I'm going to rewrite this. Write many powers as a single power. We're going to define this in a second. Evaluating means put in your calculator and get a number. What does that mean? Okay, let's go over the anatomy of a power. Okay, so let's say I have 4 to the power of 3. So this whole entire thing is called a power. And there are two parts to a power. Inside a power, there is a base. In this case, the base is 4. And there's also an exponent. But the whole thing is called a power. Now, if I were to evaluate this, what I would do is put it in my calculator and I would get the number 81, because that is 4 to the power of 3 is 4 times 4 times 4. Let me double check that. It is 64. Sorry, 64. Okay, so evaluate means put in your calculator and get a number. In this unit, simplifying means write many powers as a single power. Now, before we get into it, I want to remind you of the difference between, when I say it out loud, it sounds exactly the same, -2 to the exponent 3 and -2 to the exponent 3. So you can tell that the big difference here is the set of brackets. So what powers actually represent a repeated multiplication. So what that means is we take the base and we multiply it by itself to the number of times that is represented in the exponent. So for example, this would be -2 times -2 times -2. When you put that in your calculator, it evaluates to -8. -2 to the power of 3 has a negative on the outside, and then the base of 2 is multiplied 3 times. And that's because in this case, the 3 only impacts the 2, whereas when you put brackets around -2, the 3 impacts the negative and the 2 at the same time. Now, in this case, these both end up equaling the same thing, and that's because the exponents are odd. But if the exponents were even, for example, if I had -2 to the power of 4 and I multiplied that out 4 times, I would get +16 because the negatives cancel out in pairs. But if I had -2 to the power of 4, in this way, it'd be -2 times 2 times 2 times 2, which is -16. Okay, so I would like you guys to be aware of this scenario. Okay? All right, now let's get into it. The first law, which you would have learned back in grade 9, it's a long time ago, so let's review it, is the following. Multiplying powers is adding exponents. Or in other words, if I have a base, let's call it a to the power of n times a to the power of m, the way we simplify it is we add their exponents together, and I'll explain why. Let's look at this first one. 2 to the power of 3 is 2 times 2 times 2. Multiplied by 2 to the power of 4, I multiply by 4 more 2's. for a total of 7. Well, I could have just seen that by adding the 3 and the 4 together. As long as the bases are the same, I'm allowed to just add the exponents together. So first we have to do a check. Are they the same? Yes, they are. So I can just write this as -7 to the 6 plus 1. Like that. Okay, next. So it works even for fractions. As long as the bases are the same, I'm allowed to add their exponents. And even when the exponents are negative, we just add them. We can put them in our calculator if we want. It ends up being 1/3 to the power of 5. All right, let's get into law number 2. Dividing exponents is subtracting powers. Sorry, I said that backwards. Dividing powers is subtracting exponents. So if I have a to the n divided by a to the m, I get a to the n minus m. And again, I'll explain why. If I were to rewrite this, it would be 6 6's on the numerator and 4 6's on the denominator. And when we do it this way, we can see that 4 of the 6's in the numerator cancel out with 4 in the denominator, and I'm just left with 6 times 6, or 6 squared, which is the same as just subtracting the 4 from the 6, because I'm dividing out 4 in the denominator, 4 6's in the denominator. All right, so same deal here. As long as the bases are the same, I am allowed to do that. And I'm trying to trick you here. So I have -2 subtract 7. So 1/7 to the power of -9. There we go. Now, if I look at the next one, I can see there's division. It's kind of written in a different way because instead of using the divide symbol, I have this line. But we'll notice that the bases are not actually the same. One is -4 and the other one is 4. But if we recall what we just said above about negative exponents, I know that -4 to the power of 4, because it's even, okay, that will be equal to 4 to the power of 4, because the negative signs will cancel out in pairs. So I can rewrite this as 4 to the power of 4 divided by 4 to the power of 1, which is 4 to the power of 4 minus 1, 4 to the power of 3. Okay, let's move on. Law number 3, it says, write the following as a single expression with a positive base. So I'm going to tell you what that means in a minute, but this one goes like this. Okay, if I have a to the power of n, and I raise that to the power of m, it's a to the power of n plus m. Okay, so if I raise a power to an exponent, I multiply exponents. And I mean, when we think about it this way, this is 4 squared times 4 squared times 4 squared 8 times. It's getting to a stage where it's probably a little much to write it all out. But what we can see is if we repeat the multiplication, 4 to the power of 2 8 times, I'm going to end up with 16 4s. So I can just go ahead and write it as 4 to the power of 16. All right. The next one, we can just multiply the exponents. Oops, 3 times 3 is 9. Okay, and then what do I mean as written as a positive base? Well, when I look at this, -13 to the power of 9, I know that is an odd exponent, and I know that I could write this out as -13, -13, -13, for 9 times, and that would make it a negative base. Here I have negative 13 is my base, which is a negative number. But we said that if it's an odd exponent, I know my overall quantity is going to be negative. So there's an easier way to write this. I can write this as negative 3 to the power of 9. Slightly different, I have negative, and in this case, the 13 would be repeating 9 times. But here my base is positive. Okay, because it's 13. All right, next one. So it still works with fractions. 3 over 4 to the power of negative, to the exponent negative 5. All right. So we're almost there. We're going to end at law 5 today. But today we'll look at law number 4. Law number 4 says negative exponents are reciprocals. What does that mean? Okay, so we talked about this in our last class. If I have a over b to the power of negative n, I can take the reciprocal. Okay, reciprocal means switch the numerator and denominator, and then my power becomes positive. So this isn't meant to be a trick question. 2 is the same as 2 over 1. So I can write it like that. And then I do like a double step in 1. I'm going to take the reciprocal of the fraction, and I'm going to change the exponent to be positive at the same time. Okay, so now I'm doing a double step here too. I'm going to use law number 3 to simplify 3 to the negative 4, or 3 times negative 4. So I get negative 1 to the power of negative 12. Negative 1 we can write as negative 1 over 1. I know it looks a bit weird, but that's okay. Now I can take the reciprocal of this, 1 over negative 1 to the power of positive 12. But this ends up just being negative 1 to the power of 12. And we said that negative bases to the even exponent, well, we're going to have an even number of negatives multiplying each other. So the negative is going to go away. And because it's 1, the answer here is just very simply 1. Same deal here. I'm going to multiply the exponents. I get negative 10, and I'm going to write it as the reciprocal to a positive exponent. Law number 5 is kind of the easiest and the easiest one to remember, but the kind of the hardest one to explain. I'll try though. Anything to the power of 0 is 1. In other words, a to the power of 0 is 1, where a can be anything. So, I mean, these ones are kind of easy. You just look at them and the answer is 1. But I'm going to tell you why. Okay, and the reason is because anytime an exponent is 0, it means you have the same number of items in the numerator as the denominator. Let me give you an example. 8 to the power of 3 over 8 to the power of 3 over 8 to the power of 3 is 8 times 8 times 8 over 8 times 8 times 8. It's 1. But we also know if we were to use the exponent law for division, this is the same as 8 to the 3 minus 3, which is 8 to the 0. So I know that 8 to the power of 0 is always going to equal 1 because I'll have the same number of 8s in the numerator as the denominator. And this goes for anything. If I have 1/2 to the 0, well, that's like me saying 1/2 to the 5 minus 5, which is the same as saying 1/2 to the power of 5 divided by 1/2 to the power of 5. This is just 1 because the numerator and denominator are the same. I know it's a bit confusing, but good for you. You just kind of have to memorize that anything to the power of 0 is 1. Okay, guys, I hope that helped, and I will see you soon. Sorry I'm away today.